Hey guys, Adam here with yet another arcade game repair for you, and this one happens to be, what is it? This is Space? No, is it Space Firebird? I don't think it is. What's the other one? Space Demon. It's Space Demon. So back in, I think, 1980, Nintendo made Space Firebird and a clone called Space Demon. Space Firebird, I believe, got licensed to like Sega Gremlin. And Space Demon got licensed to, what is this, Fortrek? Never even heard of them, but that's who they licensed it to. And so they made a cocktail and an upright version. And this is the, I think this is actually a cocktail board set, but they're probably the same, right? But anyway, this comes to us from Bradley Lutz. And interestingly enough, he actually won the opportunity to have me fix his board at an auction. And so the Midwest Gaming Classic organization contacted me a while ago actually and asked if I would be willing to donate something for their silent auction, and I said sure. And so I whipped up a gift certificate really quick, and it says here, good for one free Nintendo PCB repair of your choice and a bump to the top of the repair queue. And I guess that sparked a lot of interest because, as you guys know, I have a repair queue where I keep tabs of people who are looking to get their boards repaired, and it's pretty full. It's like 20 something. If it takes me a month to do a board, given my busy schedule, then that's years out. And so people were really bidding on this, apparently, he said, and he outbid them, and so here it is. So I got a box in the mail. I'm like, I didn't expect this box, and I opened it up, and there was the gift certificate. It's like, all right, I better jump on this. So I guess I contacted Brad, and he said the word is that somebody did attempt a repair on this. Things did not go well, his words, and he finally got it back into his possession and sent it off to me. And so not really knowing what the status is of this, we're going to dig in and then figure out what's going on and get it working 100%. So I attempted to hook everything up to the Nintendo power supply that I have here. And this is, the standard, where are they? The standard black, Nintendo connectors that would go right over there, and right over here. But there was quite a bit of play. So I don't know if these are just, a little bit thinner than, say, the Donkey Kongs and the Punch-Outs and all that business. Well, Punch-Out doesn't have them, but so yeah, I noticed that, I was measuring 5 volts. I had like 2 volts or 1 volt, and I would wiggle the connector, and it was like 4 or 5, back to 2, and I was like, all right, that's a little too sketchy to play around with. So I just have some temporary, long time ago, I actually took a fingerboard and hooked up some clips so that I could use this on pretty much any PCB. If you know where to connect, 5 and ground and 12 volts and all that good stuff, then you can use something like that basically in a pinch to hook up a board of any type, really. So that's what I did, and so we should be good to go. Let's turn on the monitor here, and then turn on the game. Monitor's coming up, and then we'll turn the game on. Nothing. Okay, so black screen. So I think what I'll probably do is check for simple things like clocks and everything. I suspect we'll be okay. It did look like it found sync. Try that again. Yeah, see, I see something like some garbage on the screen, and then it looks like it found some sync. And so I'm suspecting the clocks are okay, but I'll check anyway. And then what I might do is just, this is Z80 based, you can see it's right there, and so maybe I'll throw the fluke on there and just make sure the CPU PCB is 100%. And then if it is, and I can prove to myself the program is running, then we can move on to the video PCB and take a look there. So anyway, make some room here. We'll hook up the fluke pod and go from there. Alrighty, so I started poking around the Z80. And one pin that caught my eye was the interrupt. And so quite a few of these signals, of course I'm pointing here, but I'm looking at my little cheat sheet over here. So quite a few of these signals were tied high. They're just high all the time. But that's kind of expected. When you look at the schematics, you can see that there's quite a bit of stuff that's tied high. MNI, was it NMI, non-maskable interrupt is high, bus request is high, da-da-da-da-da. This guy here, interrupt 16, is not high. It's actually fed from a flop. And so I checked him out. He looked like it was high all the time. We expected to be doing something. The clock was floating. And so the clock comes up. It says INTR sheet, I think that's supposed to say sheet 1. And so that means it comes from another sheet. So this is actually sheet, what is it, sheet 3. Maybe it's actually sheet 2, because I peeked over here, sheet 2, and sure enough, up right about here is INTR. So that's the interrupt, sheet 2, and it's fed by 2F pin 6. And so, because what I typically do is, in a case like this, if I see a signal like this that's coming in and it's floating, I want to make sure that what's driving it is floating. Because what can happen is the trace may get cut right on the board. Somebody's making a repair or damages the board or something happens, it gets scratched. And so, yeah, it's floating here, but maybe the other guy is actually driving it. So that's why I wanted to check. I can see that as it comes in, it's floating. I want to see that what it's coming out of is also floating. So it's pin 6 of 2F. And if I grab my probe, my trusty probe here, where are we? 2F, right over here. 1, 2, 3, 4, 5, 6. See my light's not changing at all? There's ground, so it would be darker, brighter, nothing. So this guy here is not doing its job. You can see it kind of goes high for a second, but there's nothing going on here. This is a 74 LS10, and that's what looks like a NAND gate or something. I'm pretty sure I have those. So let me pull that guy, and then we'll see what progresses. That's my meter letting me know that it's been on too long. So yeah, I will swap that guy out, and then hopefully we'll see a little bit of something going on. Okay, so we have our new part in there. So why don't we make sure that we have a clock now? So what we were looking at, these guys right here, right? 11 is the clock, 11 of 3D. So 3D is here. So 8, 9, 10, 11 is toggling. Great. So let's take a look at the output. And it is still high all the time. Alright, well let's take a look at the input. 8, 9, 10, 11. Look over my shoulder. Looks like it's pin 12. And it's low all the time. Interesting. So this signal here is low all the time, and it comes from him. So let's see if his input is low all the time. Pin 2 of 3D. Pin 2. So it's actually toggling. And the clock for that guy is 3. It is also toggling. So interesting. So even though the input is changing, which is good, and we got a steady clock, the output, which is pin 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, is low all the time. So it could be that this is bad, or it could be the timing. Every time that the clock goes up and takes a snapshot of the signal, it happens to be low. We really don't know, right? Because this thing is just, this logic probe just tells us it's toggling. It doesn't tell us what the signal looks like. And that's kind of limitations of when you use logic probes. It lets you know, kind of in general, if you have signs of life, what does that life really look like? Who knows? And so in order to get a glimpse of that, we need to use the scope. And so why don't I do that? I will hook up the scope, we'll hook up that data line and the clock, and then we'll know right away whether it is the part or it's just the timings. So we are all connected up, and here's what we see. And so you can see, actually I'll do, let's see, yeah, actually that's perfect right there. Hopefully you guys can see that. It's a huge glare. Maybe if I point it up like this, you can kind of see it better. But you can see, every time the clock goes up to take a snapshot, the signal happens to be low. And so that's why we're getting an output that's low all the time. Now, what's the purpose of having something like that if if it's just low all the time? I don't know if it's supposed to be low all the time. It looks like the input is fed from the address bus. So it looks like it's like a software generated interrupt or some kind of business going on there. So maybe the software is not running properly. That could be, we haven't even gotten that far yet. But we did solve a problem, right? This was definitely an issue where the clock wasn't being generated properly on that other sheet. So that's good. We got something out of the way. Now I think it's safe to go ahead and throw the fluke on there, and hopefully we can get some meaningful results. So we'll do the standard, RAM and ROM checks and that whole deal, and then we'll get a better idea of where we're at. So we did spot a couple of ROM issues, one of which is 5K and one of which is 5I. And 5I, interestingly enough, is failing in a different way every time. For example, the address range here is 18001FFF. The signature is F38A. So that's kind of what I have punched in here. So go ahead and do your check. It should complain and tell us the signature that it got as opposed to the one that we're looking for. Okay. So notice the signature that it got was 97F6, not the one we wanted. Now if there's a couple of bits that are messed up, then that's fine. It would give us a bad signature, but that bad signature should stay there. It should have the same value every time we test it. But if you watch, let's repeat this test. Remember this number, 97F6. Repeat it. And should fail again. Now it's 4D05. So it's like the internal circuitry in the ROM is screwed up such that it's giving us just garbage, random garbage every time. And so there's two ROMs in question that are messed up, 5K and 5I. And so I'm going to go ahead and reburn those with my programmer here, and then we'll see if that improves anything. ROMs are looking good, but more importantly, what button do I push here? This one. Ta-da! I think we are looking good here. Space Demon. You can see that the star field is scrolling, which is good. Hopefully you can see this is kind of bright in here. It's a nice sunny day outside. And made by Nintendo for Fortrek. Awesome. Tell you what, let me hook up my speaker here because the soundboard is sitting here. I have not verified it yet. So let's hook up a speaker and then we can coin it up and hear some cool sounds and see if everything else is working as it should. Alright, so we have a speaker hooked up over here, and since that has a built-in amplifier, we should be able to just hear sound. So let's coin this up and maybe take a couple of shots here and see what we hear. So I'm going to fudge it like so. Alright, so we're loaded up. Now I don't hear any sounds. Oh, here we go. So there's like some background music. Not hearing too much though. I gotta imagine there's more to it than that. Let me try shooting with my little guy here. Yeah, I don't hear any shooting sounds at all. Nothing. Just a little kind of background melody that plays. Let me just try a little bit more here. Yeah, there's nothing. Huh. I'm not too familiar with the game, but I gotta imagine there's more sounds than just this. And so, tell you what, why don't we load up this game in MAME, and we can kind of do a comparison. I'll also check out some videos on YouTube. But for starters, let's go ahead and fire it up in MAME, and then play a little game real quickly, and we can figure out maybe there's some sounds we're missing. So here we have Space Demon loaded up in MAME. And Space Demon, like I said, is a clone of Space Firebird. So I actually have the Space Firebird samples loaded up on the left here. So you can see there's a few samples here. When you die, I guess, that's probably what E killed is. Or maybe enemy killed, so maybe that's when you killed the bad guy. A couple of explosions, ship fire. So these are analog sounds that are not emulated in MAME. And let's see what they sound like. So we're coiling this up here. And get a couple shots off. Yeah, see, there's so much more going on. Let me turn this up so you can hear it. Yeah, there's a lot more. So it sounds like, to me, well, there's a couple things, right? One is there's this blue haze that we're not getting on the video. So just notice that. The other thing is the analog sounds. And so it sounds like we're probably getting digital sounds on the board, but we're not getting analog sounds. So why don't we go back to the schematics. We'll see if we can figure out where the analog sounds are generated as opposed to digital, and then that'll give us an idea of where we need to start poking around over there. Alright, I haven't figured out all this yet, but certain things are popping out at me. So, for example, this is the sound generator for the digital sounds. So it creates a digital sound, and in digital, obviously, and then it converts it to analog right here. This is a DAC. And so that kind of works its way through this amplification stuff. Heads up to this main amplifier and then out to the speaker. So that's where the digital sounds get created. If you look, not only does the digital sound work its way up to this main amplifier, but there's stuff coming off on the right hand side here. So if we follow that down, there is some amplification here. More importantly, there's a 555 timer. Now we've seen this on Donkey Kong to create the periodic jump sounds and that sort of business. So that's probably what's being used to generate like the shooting sounds. So I can see that it comes through here and feeds up into the circuitry. Again, I haven't traced all this out yet. I can see that it feeds into some other points in here and then work their way up. So anyway, I think this is generating like the shooting sounds, and maybe the enemy death sounds, because they sound pretty similar and they're very periodic. It's like ooh, you know. You can tell there's some kind of analog wave going on there. This down here, these are shift registers, and whenever you see shift registers, those are used primarily for white noise. And so I think the enemy, when he dies, it's kind of like a, you know, almost like the or Donkey Kong jumping, right? We saw that in the Donkey Kong sound circuitry. When Donkey Kong is jumping in the beginning of the game on the girders, that's all white noise. Those are generated by shift registers. And so I think this is the enemy sounds exploding, or whatever you want to call it right here. But we're not getting any of this. So that actually might not be bad. It might be something common. Like I know there's a clock signal that goes in here, kind of drives some of this stuff. Maybe it's something common over here. That'd be great. I don't know. I'll start poking around. Again, I don't have this completely nailed down yet. I just started looking at it for a little bit. But at least I can identify some key pieces here. And then based on that, we'll dig in a little bit further and hopefully figure all this stuff out. Alrighty, found something. So rather than dig into all this mess, there's a lot of analog business going on here. I figured I'd stick to this because this is a little bit more my home turf here, digital. This is all digital stuff. This, of course, is the noise generation for the explosion sound, which we're not hearing, so we know this is not working. Good place to start. So I figured I'd start the clock. So I'm looking at the clock for IC14, and it's just low all the time. Nothing's going on. So I trace that up to this guy, which is an inverter. So the clock comes in, you just flip it, and then you send it down to the this shift register here. So if we look at the input and the output of that guy, which is right over here, LS04, and so 1, 2, 3, 4, 5. That's our input, looking good there. The output, it's just low all the time. So how are these other ones doing actually? So that comes in. That doesn't look right at all. These should be opposite each other. Coming in 0, going out should be a 1. Coming in, this is floating. Well, that's okay. It might not be used. But this guy here, he's coming in. He's toggling just fine. And he is just pegged low. So this guy is garbage. Let me pull him and see if we get at least our explosion sounds back. Okay, let's test out our engine sounds here. Oh, well that's promising. We didn't hear that before. Let's coin it up. We'll let our guy die. And see if we get some crash or explosion sounds. Hey, alright. So that took care of that. I don't imagine we have our other sounds back though, right? No. Pew, pew, pew. I didn't hear any of that. Alright, well, we got one down. We got our explosion down. So let's see if we can dig into this a little bit more. I'll start poking around the timer, make sure that's generating a good clock. Might have to use a scope for that. And then kind of work my way in this direction, and maybe we'll get lucky. Alright, so I think I found another bum inverter here. This inverter here generates a clock that kind of goes down and feeds this stuff here. And it's another one of the, well, this is an 05. The other one we saw was an 04. But it serves the same purpose. It's an inverter here. And if we check pin 1, let me move my hand so you guys can see, we have a good clock. And then check the output, garbage. So another bad one. And I've seen this before. I don't know why. But I think if you look back at some of my other videos, man, I'm always replacing these 04s and 05s. I don't know what it is, but they're always going bad. Anyway, we pull this guy and see what else we got left to do. So still no shooting sounds, but I spent the last, I don't know, hour or so really looking at this, and I think I've made some discoveries. The first thing I did actually was identify what some of these inputs are doing. And so I hooked up my logic probe onto, basically these inputs. I played the game and I, moved the guy around, shot him and stuff like that. And what I noticed is that this guy here, pin 6, he always toggles when I shoot something. And then pin 7 toggles when the enemy dies. Okay, so that's good because it allows me to kind of figure out what these different blocks are doing. So down here we've got our shift register. We already know that generates the sound when your ship explodes. Originally I thought it was, when the enemy explodes. It's actually when you explode. So that's for you. You can see here enemy dies, kind of feeds in this way. And then it turns this guy on. We'll get to that in a minute. But it also, what does it do? It comes in this direction, it fires up this amplifier, which is looking at this 555 timer. So what this 555 timer is doing is generating a tone, and then when your enemy dies, it kind of fires up that timer, but in addition it fires up this guy, and we'll get to that in a second. So this 555 timer, I believe, is what is being used to generate the tone when the enemy ship dies. This guy here, when you shoot, it does some stuff over here, but it also comes up into this business, and then what does it do? It works its way over into the main amplifier. What caught my eye was this signal here. It goes up into all this business. This is all video signal stuff. And so I was trying to figure out why in the world would they be picking that off, and then it occurred to me, you need an oscillator to generate a sound, right? And so in the case of your enemy ship dying, we're using this 555 timer. I believe, and I haven't confirmed this yet, I think the oscillator that they're using is like some form of the vertical blank signal that gets sent to your monitor. I can see it gets fed down here through a diode, and these two guys are fighting each other. And as long as this guy is on, then it's kind of overpowering. It's not going to be able to send a signal this way. But if this guy goes low, then this signal is allowed, or maybe it's the other way around. Then this signal can pass through, and it goes through this amplifier, and out the door to the speaker. And so I think what they're doing is they're using the vertical blank, or the video timing, some form of that as an oscillator for you shooting your little whatever it is, your little pew 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 at the enemy ship. So that takes care of that. What I think these are enables to what I think is like a preamp. And so when either you shoot or the enemy dies, if you trace these signals out, they fire up these two guys. One of these is for when you shoot, one of these is for when the enemy dies, and it goes up to this like little preamp. And so I think what happens is, this is like an OR gate, essentially. It's like a big analog OR gate. When you're doing one or the other, we're going to fire up this analog preamp, and then that will preamplify the signal before we send it up, to the main amplifier as it works its way out. So I think these are enables. I think this is the preamp. Is this a preamp for both? I'll have to take a look and see. Well, yeah, it is, obviously, right? Because this is an OR, and it's feeding that guy up. So I think this is like a preamp for your shooting and when you die. I think that this is a little preamp for the DAC, right? So this is the music and everything else. And then it all comes together and goes through the main amp. So I think what I might do is kind of just circle some of these lightly in my pencil and then comment them, so years from now or months from now, whenever, when I work on another board of this type, I'll quickly remember what all this stuff does. So long story short, I think I have this pretty well nailed down. We'll see. I'll kind of base my assumptions on that. I'll work through it and we'll see how it goes. I really want to figure out what's going on with the shooting. That's bothering me. So I'm going to start from there, work through some different points here, make sure the preamp is turning on with this business here, make sure that the signal from the vertical blank is working its way down and feeding into the amplifier and all that kind of good stuff. So I think we're making headway here. Let me just continue to poke around and hopefully we'll get some shooting back. Okay, so I'm looking at these guys over here that switch and turn on that preamp business. I'm noticing that this switches on correctly. The emitter side switches correctly, but when I measure this side, it's always negative 5 volts, and that's what's down here. So I'm wondering if like this cap here is bad. This is C7. Where am I looking? Way over here, C7. I can see that when I switch on, this is the base of the transistor, boom, it switches on. Nothing happens at the positive side of that cap. And this is an electrolytic cap, so like the caps in your, this electrolytic cap, so like the caps in your monitor, they can dry out and go bad. And so I wonder if I have a couple of these. If not, then I'll probably have to order some and then continue this when they come in. But let's see what I got in my little stash. Alright, well, quite some time has passed. In fact, I think it was like a month since I recorded the last little clip where I discovered we had some issues over here. But that's what happens when you're in the middle of summer and you get good weather. You want to be outside and do other things, and so I encourage you to do that. So anyway, where were we? Yes, we were replacing some caps. I think there were some issues here that we thought that the caps were suspect, and so what I did is I just recapped this entire right section of the audio PCB. This is all digital logic. This is all the stuff that's going on up in here, and all this analog business is over on the right-hand side. And so I figured, if these two are bad, then why don't I just, since they're pennies a piece, just replace all the caps on that half of the PCB. So that's what I did. Then I threw my scope on there, and I saw that, aha, this was now switching. And so whether the enemy ship is dying or whether I'm shooting, these guys would fire up and would enable that amp over there. So that's what we want to see. But I was still not getting any of the sounds, either when the enemy ship dies or when I shoot. And so I took a look at this. I said, all right, well, when the enemy dies, this 555 is generating, you know, a signal, something that's wiggling, and then it kind of feeds through this business and then feeds up into here. When you shoot, it actually uses the horizontal, I think, blank signal or something, pours down in here, and then comes into this business. So what do these have in common? It's kind of this whole section here. We've got IC25, which I think is this guy right here. And then there's IC24, which is these two guys, which is actually right here. And so I checked, and I didn't have IC25, but I had plenty of these guys, the IC24, which I think is just an LM324 amplifier. So I figured, all right, well, why don't I start with that? So I threw it in there, and bam, we got both enemy dying sounds. I don't know how you want to say it, but we also have our shooting sounds. So let me coin this up. I'm going to switch hands here for a moment. And we'll coin this up here. And of course you'll hear the digital sounds, but more importantly, if you can hear that, hopefully you can. Let me move this over here so you can hear it. It's kind of like a little chirping sound. And I had to actually listen to some videos. I think Todd Tuckey from TNT, he actually gave a demo, and that was one of the only demos that I could see of the actual hardware, not MAME, to see what it sounded like. So you can hear, like when I shoot, you basically hear a little chirp, and then when the enemy dies, it's kind of like just do it one more time here so you gotta get a listen to it. It's me shooting. Try not to die here. There you go. I'm gonna die. But anyway, long story short, we got it, right? So the video looks good, the sound looks good, and I think that's pretty much it for this guy. What else do I need to check? Sound, video, player input. So I'll do that off camera. I'll go ahead and make sure that I can move my little ship around and everything else. But aside from that, I think we're in good shape here. So yeah, lots of stuff going on with this one. Sorry it took so long, but hey, like I said, it's summer and we should really be outside. I mean, look what a beautiful day it is out there. Why are we sitting in the lab doing this stuff? So anyway, let me wrap this up so I can go outside and play. And I guess that's it. So God bless you guys. Thanks for watching, and we'll catch you on the next one.